Hey, so today we're doing flow simulation around a cylinder that's 2D, and we already had our values lined up and tabulated. So we're gonna go ahead and create our mesh with Design Modeler, and our mesh is just a circle with 1 meter diameter, and then we're gonna create a rectangle that's 50 meters by 50 meters. And that's going to be centered over our circle, which is just going to represent our cylinder. So here we're centering our values and our dimensions, and we can go ahead and convert this to an actual surface to work with after we set our dimensions. So we're adding a method here to triangulate our mesh, and this is what it looks like here. So we're gonna go ahead and name all our sides, including the wall of the cylinder, so that it matches up with our simulation. And then from here we're gonna add a sizing to increase the resolution around that cylinder wall, and then we're also going to do an inflation to give our, it's supposed to represent a cylinder, so to give our mesh a little bit of height, to get like a more true to life simulation. For our setup, we're doing Inviscid, and the only thing we're working with is our velocity, which is 5, and we're just making sure these values are correct. Then we're going to go and check our residuals. I was going to go for a higher value, but that would take a really long time. And for our initialization, we just computed from the inlet and ran our calculation with I think 250 iterations, and then it stopped at 173. So this is just me getting our contours for pressure, which should be a symmetrical looking contour, and then here's our velocity, which shouldn't have any disturbances in the flow, which is characteristic of turbulent flow. Everything should be smooth and symmetrical. And then here's me getting our plots for the pressure coefficient, which should be a parabola shape, and then another for our velocity, which is a semicircle shape like this. And our dry coefficient is very low, and this is good because we're dealing with Inviscid, so we shouldn't have a high number, because we don't have any viscosity, and the friction would be negligible because there really isn't any movement. And then here we're going to recreate these contours for our pressure and our velocity. And then we're going to get our streamlines to close off this segment of the project for case A.